Alright, I'd like to welcome everybody out today. Our mic battery is dead, so I'd ask that everyone be quiet. Hopefully you can talk loud. This is Wim, and he'll be talking with us today, and we'd also like to thank our sponsors and everything that they've done to help make this conference what it is. So,
thank you. If you can't hear me well enough at the back, then just raise your hands and indicate that I need to speak loud. So, we're going to talk about caching, tuning, scalability, a lot of stuff to handle, to deal with in about an hour. Let me quickly tell you who I am. My name is Wim Godden. I'm from Belgium. For those of you who don't know where that is, it's the dark green spot in the center of Europe. That's known for Belgian beer, Belgian chocolate, and other tasty, yummy things. Or odd-looking buildings. This is an iron crystal magnified 65 billion times. Yes, you can walk inside, and apparently I found out a couple of weeks ago that it has the highest toilet in Belgium. I live close to Antwerp, and in a town where we have a beautiful abbey and a couple of castles and stuff like that. All very nice. It's not all good news though. In Belgium we have a bit of a traffic problem. This is what happens when we have snow. Then we get a traffic jam, 2,500 kilometers of traffic in a country that's only 250 kilometers across. And smack in the middle of that, I started a company about 15 years ago called Cube Solutions. We do mostly PHP, but also a lot of other stuff. Nginx, clustering, anything with scalability. I've been doing open source since around 1997. Worked on stuff like PHP compatibility. Anyone using PHP compatibility? Anybody? Okay, if you ever want to check if your code is compatible with the next version of PHP, then you can use that tool. It will tell you you're using this extension that's not going to work in the next version of PHP. So it's kind of a nifty tool. It's not PHP 7 ready yet. It will be very soon. And I've been doing talks like these for the last couple of years. Let's see who you are. Who here is a developer? Any system engineers or network engineers?
Part-time.
Any managers? Some of you are all three. Yeah, that's pretty nice. Okay. Anyone here with caching experience? And I don't mean installing Drupal and ticking the checkbox that says, yes, I want caching. Anyone ever build a site with a lot of caching in there? Okay, good. So, the goals of this talk is, I want to talk about everything related to caching and tuning, right? Nah, I'm not going to do that. It's simply impossible. I'm going to touch on a few things, basically how to do stuff and how not to do stuff, the most common techniques. There are many other ways to do stuff. This is just one of the ways. The goal is to increase reliability, yes, but mostly performance and scalability of our site, of our application. Basically, we want to get from 5 visitors a day to 500,000 a day without having to rebuild our entire code base, rebuild our entire architecture. If you want to become the next Facebook, don't expect me to provide some kind of miracle cure here. I'll get you a few steps along the way, but you'll have to look elsewhere as well. Okay, we're going to start from a stack that most of us are familiar with, the LAMP stack, so Linux, Apache, MySQL, PHP. So, we have a database server, we have a couple of web servers, we might have a load balancer in front of that, so we're going to start from this, and what I'm going to do, I'm not going to do live benchmarking because that's always a very bad idea. Okay. Ooh. That's weird. It's always a bad idea to do live benchmarking during a talk because stuff will always go wrong, of course. Plus, I don't have a couple of web servers with me here, of course. So I'm going to show some graphs from a previous benchmark that I did. So basically, let's say we have a test page that asks 3 database queries. It doesn't really matter what the database queries are. We have SQL caching, query cache disabled, and all of that stuff. And the page will just output the result of these 3 database queries. And we're just going to run Apache bench across them. So we just want to see how many times can we hit that page per second. For example, in this case, this specific setup that I did, when we run Apache and PHP, and we run on static images, for example, we get 3,900 requests per second, which is kind of nice. And on PHP, we get 17.5 requests per second, which is not really that great. If we run it through our proxy, which was in front of our 2 web servers, then obviously we get almost twice as much on static images. However, we do have a little problem here. Our PHP doesn't really go up. And the reason is that the static is limited by anything like CPU, network, disk related, but our PHP is limited by our database. So we cannot get our database to process more than that many requests, many queries. So we need to fix that problem. And at the same time, we're going to try to fix that problem as well. We're going to try to increase both. So let's talk about caching. What is caching? Well, caching basically means you take a piece of data, any piece of data, it could be anything you want really, and you store it in a location where it is a lot faster to retrieve it next time. So, quick example, let's take a mathematical calculation here. We have certain parameters that we supply to that mathematical calculation. The result of that is always going to be the same. There's no point in calculating that thing over and over again. If that takes 20 minutes to calculate, which it probably doesn't, but let's say it does, then we should only do it just once. And then we store it in a cache. Next time we need that result, we just retrieve it from the cache. A lot faster. Same thing with a database query. That database query might not change. If it does not change a lot, we can just store it in a cache, retrieve it from there. It might be a lot faster. So the goal of caching is obviously we want to reduce the number of requests and we want to reduce the load at our source of information. That source could be a database, but it could be some kind of web server with an RSS feed, or it could be a SOAP API or a REST API. It doesn't really matter. We want to reduce the load on that system. At the same time, we want those results faster. So we want to reduce the latency. That's good because we can reduce the amount of time our visitor, our user of our application has to wait. At the same time, it also means we can process the next request a lot faster. If we are limited in how many simultaneous requests we can process, the sooner we have additional requests available to us, the sooner we can handle it. And of course, we want to do something on the network. We want to send less data to our visitor, our user. That, of course, is related to front end, which I'm not going to talk about a lot, but I will get back to the front end in just a little bit. So, let's say we want to cache stuff. Our user here is going to make a request to PHP running on Apache or whatever, and it's going to request a certain page. Now, this might be a little bit small in the back, I'm sorry for that. It's going to request a certain page, and PHP is going to say, okay, I need this specific piece of information. Let me check if I have that in my cache. And so PHP is going to request a cache for a certain key, a certain item. And the cache is going to say, nope, I don't have it, sorry. It's going to return false or null or whatever that specific caching system will return. Then PHP is going to request that information from the database. It's going to get back all the rows that it needs from the database. And then, of course, it's going to push it to the cache with this specific key. And finally, of course, it needs to return a page. This is what we call a cache miss. The information was not in the cache, so we got it from the original source of the information, and we put it into the cache. Now, our user presses F5, refresh. We request that same page. We go to the cache. We say, give me this specific information. And now we get a cache hit. And we get that information directly from the cache. We're no longer hitting the database. A lot faster, a lot easier to do. Now you might wonder what happens when the database changes. Well, we'll get back to that a little bit later. So there's a couple of ways in which you can store information in a cache. A couple of ways you can do it for web applications. The old way was to store entire pages. This is still a very good way to do it for blogs or company pages that don't change at all. But usually there's small snippets on each page that changes every now and then, like the latest news and stuff like that. So that doesn't work. You can store part of a page, like a page blog, which is the most commonly used system. Or you could, as I showed before, you could store the output of SQL data and then just retrieve that information, process it, and output stuff to the user. Or you could store what we could call complex processing result, which could be something like retrieving an XML feed, parsing it completely, and then store that in a cache so that you don't have to retrieve and parse it every single time, which saves you a lot of time. But anything really is your call. The only limit here is your imagination. When you have a piece of data, what you need to think about is, how long did it take me to create this data or retrieve it from somewhere? How often is it going to be changed, updated, and how often is it going to be retrieved? So for example, if you have a piece of information that takes 10 minutes to retrieve, and it's not being updated regularly, well, cache it, because the next time someone asks for it, it's going to take you 10 minutes to get it. If, however, you have a piece of information that changes every second, and it only takes you a millisecond to retrieve it, don't bother caching it, because it's going to change every second. So you have to update your cache every second as well. How do you find cacheable data? Well, for new projects, some people don't like me saying this. I say, start from the principle, I'm going to cache everything. And the reason for that is, if you have to build a caching layer into your projects, then usually you have to structure your project in a way that is, well, I would say better than when you don't build a caching layer. Because you have to take into account that data is being inserted into that cache in a logical way, with logical names, logical key names, and stuff like that. It's a lot easier to start from the principle, I'm going to cache everything, and then later on say, oh, I don't need to put this in the cache. Then building an entire project and then deciding, maybe I should add caching somewhere. It's going to be a lot harder. For existing projects, there's a couple of things you can do. You can, of course, check page loading times. If you have a page that takes 10 seconds to load, it might be worth investigating why exactly that's taking so long. You could look at the slow query log. MySQL has one, Postgres has one, Oracle has a way to retrieve it. This is basically a log that will tell you how slow certain queries were. Like in MySQL, it will tell you, okay, this query took 1.5 seconds to complete. So maybe it's worth looking into whether we can optimize that query. You can also do complete query log. Very interesting for MySQL. A complete query log will actually list all the queries running on your system. Be careful if you do this on a production environment where you have maybe 10,000 queries per second running, because this will create a huge log file. So turn it off as well. And then you can use that query log and run it through a tool called PD Query Digest, which is part of the Percode toolkit. If you do that, it will give you output that looks a little like this. So it will give you a number of queries, and it will aggregate similar queries. So if only the, like it says, where ID equals 5, and the next one where ID equals 6, will consider those queries are identical if the rest of the query was identical. And then it will group it, it will order it by the time spent on processing those queries. So in this case, you can see that these queries are all quite good, except for the first one, which takes more than 13 seconds to complete every single time. So that's definitely a query to look at. Now, below this, there's even more output. I couldn't fit it all in one slide, because per query here, you get all of this. Now, this is way too small to read in the back, I know. But basically, this tells you, I spent this much time waiting for a log. I spent this much time looking through indexes and so on. And then you can dig deeper into why that query is actually running so slow. Now, if we're talking about caching, of course we need to store our data somewhere. All systems used to store data on disk a lot. It's very useful for data that doesn't change a lot. I would not use it to store the output of SQL queries. It's not really that fast. Whatever you do, please do not use NFS or anything like this or any other network file system to store caching data. Oops. Why not? Well, you've got a high latency, you're storing stuff over the network, and you've got problems if you use sessions, for example. Some people still put their sessions on NFS so that multiple servers can access the sessions. but that can cause locking issues, session corruption, and so on. If you're using disk or RAM disk, the other problem you have is that you're storing stuff locally. Which means if you have 5 web servers, you have 5 local caches. So if your data changes, well, you're going to have to keep them synchronized somehow. Please don't use NFS for that, and whatever you do, don't use rsync for that. So the alternative is not using disk or RAM disk. The alternative is using a system like, for example, Memcached. Anyone here ever worked with Memcached? Quite a few hands. Good. So Facebook uses, Twitter uses, YouTube, and so many other thousands of sites use it nowadays. It's a distributed memory caching system, which basically means it's going to spread all of its data across multiple machines. And those multiple machines together form one big hash table. So you can have 2 systems with each, let's say, 128 megs of memory available to Memcached, and together they will form 256 megs of global hash table space. It's a key value system, basically meaning the keys have value attached to it. The keys can be up to 250 bytes, and the values can be up to 1 megabyte. And it is unbelievably fast. It just sits on the network. You can just connect to it through TCP, or since Facebook added UDP support, it's even faster now. And it is non-blocking. Basically, this thing can handle tens of thousands of requests per second. And it can handle tens of thousands of simultaneous requests per second as well. There's a lot of different variations of Memcached. Some of them using the standard protocol, some of them using slightly modified versions of the protocol. There's couch-based, there's plenty of others. I'm just using Memcached as an example of a memory-based caching technique.
So, question, what kind of hardware are we talking about there to get 10,000 requests per second? Gotta be, and what kind of record size?
Memcached is so fast, you can easily get that. I mean, if I'm talking about tens of thousands of requests per second, you could probably do that on, let's say, a very slow Xeon CPU that's 10 years old.
So, 2 gigahertz?
Yeah, definitely.
Okay.
No problem at all.
And what kind of record size we're talking about? I'm sure if we make the record size big enough, we will get that.
Yeah, if you put 1 megabyte in there all the way, then you would get in trouble.
So we're talking 10K records?
Yeah, or less. Usually, the stuff you will store for most web applications is very small. It could be a block of information like a news item. So it could be a couple of 100 bytes even. The bigger you make it, the slower it's going to be. So normally you would install it, you could install it on your database server, since you're trying to take away load there. You could do that. Most people install it on web servers, or if you really have a very big setup, you have dedicated Memcached servers. Facebook has many of those running. And to install and run it is actually very easy. You have every Linux distribution has packages for it. If you want to look it up to PHP, there's Pickle, and Windows has binaries. And to run it, well, even easier, you need no configuration files to just run it, although most systems, most setups will have configuration. You just run memcache -d -m, and then you provide how much memory it's going to use in megabytes, then which IP address to listen to, and which port, which by default is 11 to 11. And that's all. Now it's running.
And I imagine you don't have to give the IP, it'll just bind to whatever if you...
Yeah, then it will bind to every single IP that you have on your system. Couple of notes though, it's not fault tolerant. So it's a cache, it's not designed to be fault tolerant, meaning if it crashes, the data is gone because it was in memory, it was memcached. Meaning if you store sessions in there, everyone who was logged in is now no longer logged in. Everyone who had a shopping cart just lost their shopping cart. So you have to keep that in mind, of course. There are alternatives for memcache that allow you to store information on a disk that have persistent storage. There are advantages to that, of course. Well, this thing. They are, in general, slightly slower. But It depends on which specific product you're using. And another very important note is firewall your memcache port. Because by default, yes, it will hook onto every single IP, which means if you're using a public IP, it will just open up port 11.2.11 and it won't connect to it and retrieve any information from it, which means if you're storing session information in there, they can just get that information and either log in as that user or just retrieve the information that's in there, which could be, well, worst case credit card information. So you definitely want to firewall your memcache port. And if you're using IPv6, don't forget that you need to firewall on IPv6 as well. So what would it look like in a piece of code in PHP? Well, let's say that we have PHP, we just want to store something very simplistic. We say new memcache, we add a server with a port, we add another server with a port. We're going to get some information on my key, which is where we store information. And then we're going to check, and here's a very important note, this is not the right way to do it in memcache. Yes, you could say if my data triple equals false, this is the old way. I still see it in a lot of code. It's not the right way to do it. This is the proper way. You say get result code and then you check out stored. Because basically you could be storing false in memcache. And that would be a proper thing to store, false. So if it's not stored, then we get a cache miss. Data is not in the cache, and then we're going to do something. We're going to get information from a database, and we're going to say memcache set under that same key, some data. Oh, we don't want compression, and we don't want this thing to expire. You can provide an expiration time. You can say store it only for an hour, for example. So if we go through the code and we get a cache hit, then of course we're just going to retrieve information. It's going to be in my data, and we're not going to go into this if structure. Now you might wonder, I added two servers here. Where will my key be located? Who's going to decide? Well, the thing is, it's actually not the server that's going to decide, it's the client that will decide. So the PHP client connecting to the memcache service is going to decide on which server it will be stored. And it will depend on the hashing algorithm. Now there's two hashing algorithms. There's the old one, the traditional one. Really, it's not being used anymore. If you still have an installation with it running, you should really move to the other one. The problem with the traditional one is that if one of the servers crashes, you lose one memcache server, it needs to rehash all the data from scratch. The consistent hashing algorithm allows you to, if you have 10 servers, you need to rehash 1/10 of the data. Again, there's no replication by default in memcache. There are other alternatives that do have replication. Now, if we go back to our benchmark here, let's say we add some caching, and so every time we run those 3 database queries that we had in the beginning, instead of going to the database every single time, we just fetch them from memcache. All of a sudden we see, hey, we're doing almost more than 3 times as much here. Plus, the big advantage is the limit is clearly not the database anymore. It's now PHP. It's now CPU bound. Because if we run it through our proxy, we're hitting both our web servers, and we're getting twice as much. That is a very important thing with memcache and similar systems that you should know about. Memcache can actually say, oh, you've given me 2 gigabytes of memory, and I'm only using 10%, but I'm full anyway, which is kind of weird. So the way it works is it has a system called slabs. So what it will do is it will create a slab of 40 bytes, then it will create a slab of 50 bytes, one of 63 bytes, and so on. And so whenever it needs to store a piece of information, let's say it needs to store a piece of information of 52 bytes, it will have to store that in slab number 3, which can store items up to 63 bytes. The problem is, if you store a lot of objects of different sizes, then you might get a lot of different slabs of different sizes. And certain of them will be completely full, while others will be mostly empty or even completely empty. And if you then try to store one that's in a slab that's already full, it will throw out old information. So memcache by default kicks out the least recently used data, which could be a problem if, well, you're storing session information in there, for example. So, how do you know it's working? Well, you can just connect to it on Telnet, using port 11.2.11 or whatever port you define, and then type stats, and that will give you something like this, a lot of information. It will tell you how many gets, how many sets, how many hits, how many misses, which is kind of important. If you see a lot of cached misses, that's not a good thing. It will also tell you how many evictions, so how many times it removed something because it didn't have enough space left. Or you could just use Cacti or any other monitoring tool to actually get the same information in. How do you back it up, a memcache? Well, if you try to back up a cache, you're doing it wrong, because your cache is supposed to be a copy of something that is in database or some RSS feed or whatever. So backing up a cache, not a good idea. Quick tip, if you have a page and you have multiple pieces of information there, multiple news items, multiple favorites or whatever, and you know in advance which ones are going to be on that page, then you can just do get multi, and you can fetch them all in one request. And basically what it will do is it will take that array of items that you want it to want to be retrieved, and it will automatically request the right items from the right service in one go. It's going to return that as an array. You have to be careful though, you could get some hits and some misses, so you'll have to, of course, handle that. Holding a microphone. Naming your keys. Very interesting topic always. Key names must be unique, really. Well, it's kind of important, obviously. If you're using a memcache server for more than one project, it's kind of a good idea to prefix them. And it's always a good idea to use only letters, numbers, and underscore. And the reason for that is, let's say at some point you want to switch from memcache to another technology, and there are certain limitations on the key names. If you stick to this, you're never going to get any problems switching from one to the other. Yes, you could just, to be on the safe side, if you have extremely long key names, you could say, oh, I'll just MD5 them. That way they're definitely 32 bytes long. That's useful, yes, although you could get conflicts there, and it's going to be extremely hard to debug them. So I would not do that. And you just have to use clear names and document them. We all love documenting this stuff, right? Yeah. Okay, so let's imagine that we want to update some stuff. We haven't talked about updating yet, only retrieving. So let's imagine we're Amazon.com and we have this page where we have the most popular LCD screens. And of course, Amazon is a big site. Maybe they get 20 requests per second on this page, probably more, but let's say 20. So they want to cache this, because they don't want to run a query that gets all of this information from their thousands and thousands of products, because we have, well, what do we have? We have products, we have categories, we have pricing, we have stock information, we have ratings. That's a lot of information to retrieve. So we can imagine that running a query across this page might take, I don't know, probably not for Amazon, it's not going to take that long, but in a system that we might build, it could take like 5 seconds, who knows. So we're going to cache this, and we're going to call this LCD popular product list. And now we want to update the price of this Toshiba screen. So how would you update that? What is the most logical way to do it? Any suggestions? How would you do it in memcache? Yeah.
I mean, there's several different ways, but the way I probably would approach it is I would just invalidate the cache, like delete the item.
Like that? Yeah. So you just delete the item, because the next person who will hit that page is going to get a cache miss, and then run the database query, it's going to insert it back into the database. The issue is you're going to get this on Amazon. This is actually Amazon.com going down in 2004. And the reason you're going to get that is, I said, we're hitting that page 20 times a second. So that means 10 people will hit it in the first half second. Those 10 people are all going to get a cache miss. they're all going to launch that query, which normally takes 5 seconds. Now there's 10 people running it already. In the next half second, another 10 people. In the next second, another 20 people are going to hit it. And basically what you're going to get is what we call cache stampeding, which is what happens when an entire army of elephants is hitting your database and saying, give me the data. And the database server just cannot cope with it anymore. So how do we fix this? Well, most people build a site like this. So they have their visitor interface, which is where people hit the website, and that talks to the database, and it has Memcache code, and it will interact here. And then their admin page also talks to the database, but all it does is delete stuff from the cache. And that's not really ideal. So what we want to do, of course, is put our code there in a library, and then whenever the admin wants to update something, wants to change a price, instead of deleting from cache, it's just going to run the same query and then just push to the cache, so overwrite the cache. So the rule is don't delete stuff from your cache. Now you might wonder, what do we do when our servers have rebooted and our cache is completely empty? Well, we have a system there called warm-up scripts. So you use it to fill in your cache when it's empty, to bring your cache to the optimal running condition. And you run it before you start the web server, otherwise people are going to hit 20 times a second and it's going to go down right away. There's 2 ways. You could visit every single URL on your website. Yeah. Good luck with that. Or you could just say, I'm just going to run through all my categories and all my products and run my cache updating methods, which are in the central library anyway now. And that way I'm just going to update all my cache data. Make sure you have a warm-up script, even if it's just for testing purposes. Always very nice to have it. Now you might wonder, what about locking? How about if we have a cache miss? I just put in a locking place and then I tell everyone, don't run a query. I'm running the query and I will put it in the database. I will put it in the cache and then you can fetch it from the cache. That might be a good idea, but 2 problems. While that lock is in place, you're going to get a lot of hits. Maybe so many hits, 20 per second, that your Apache will refuse at some point, will start refusing connections. The other thing is, what if that process that created the lock actually fails and never releases the lock? Then you're in even more trouble. So, don't delete from cache, don't expire from cache either. I mean, Memcache will remove stuff if it's not being used anymore for a very long time. So unless you know you'll never store it again, just leave it in there, it's fine. Exceptions are, of course, if, for example, you have a calendar item and it's being deleted, well, yeah, it's not there anymore. You can start small. You can say, okay, I'm going to store stuff in disk or, well, the ABC memory-based storage, and then move to Memcache, Redis, Couchbase, whatever you want later. Now, in order to do that, it's best to make sure that your code actually is able to switch very easily. That way you don't have to rewrite your entire code just because you change your caching engine. So stuff like Zcache or whatever you're using in your specific framework. Okay, so we started from LAMP, Linux, Apache, MySQL, PHP. We added an M for Memcache. Now we're going to get rid of the A and replace it by an N. I'm not going to try to pronounce that anymore. So, let's talk about Nginx. Anyone here? Yeah?
Sorry, I have a question about the cache stampeding. It's entirely possible you answered this and I missed it. So is your solution to that to update directly to the cache instead of, if we're not deleting and we're not expiring, we're just updating right to the cache?
Yeah.
Okay.
Always try to push to the cache. Yeah. So dynamic updates to your cache are the better way to do it.
Okay.
As soon as you start deleting from cache, then you might run into any kind of cache stampeding issue.
Thanks.
So, anyone ever used Nginx? Quite a few people. Okay. So, Nginx is a web server. It's also a reverse proxy server. It's also an IMAP and SMTP server, but I'm not going to talk about that. It is very lightweight and very fast, extremely fast. And currently it runs almost 15% of all websites worldwide, making it the second largest behind Apache. It doesn't use any threads, and it's event-driven, which makes it very similar to Memcached, actually, which also doesn't have any threads and is also event-driven. So, depending on which operating system you're on, it uses keep all KQ. And it uses hardly any memory. So,
Question.
you can connect to it 10,000 times at the same time, and it will just sit there and say, yeah, whatever. If you try to do that on Apache, well, good luck. So, yeah, 20,000 active connections, fine. 20,000 requests per second, that's just fine. No problem at all. Go ahead.
Question, so does that mean that if I'm an Nginx and let's say I have a CGI script, and that CGI script is really slow, then I locked up the whole server?
Yes. So you have to be careful, of course. It will, well, you can define how many connections it can accept. Just like in Apache where you can say, I only want 200 connections maximum, you can still do that in Nginx. By default, it will be configured to, well, whatever your distribution configures it to, but you can easily set it to, well, 8,000 connections per CPU, for example. So yes, you still have to be careful that it doesn't actually start 2,000 CGI processes at the same time.
What I was talking about is, it's one, doesn't have threads, and event-driven. So if I somehow do something to occupy, if one request takes a very long time, are we hosed completely, or are there like multiple fork processes like in Apache, where you have, you know, you tie up one worker, and then at least other workers are available?
Oh yes, yeah. So it will continue to process. So because it's event driven, it will actually how do I explain this easiest?
Time slicing.
But by default, it will not. For example, you will not be running CGI specific things straight directly in Nginx. It will hook onto a CGI processor. Like for example, I will explain in a minute. It will hook onto PHP FPM through fast CGI. So Nginx itself will not get blocked there. It might be that CGI process is blocked, but that's separately. But I'll get to that in a minute. So if we look at the configuration, if you compare it to Apache, it's very similar really. In Apache you have virtual host, here we call it server. You can say server name, which in Apache is server name without the underscore. And then index is very similar. Root would be document root in Apache. So configuration-wise, looks pretty much the same. Now, you could use it to just serve static files, at which it's very good, very fast. And then you could do something like this. Okay, I'm just going to serve all my static files, anything with this extension. I'm going to make sure the browser caches it for 30 days. And then anything else, I'm going to pass on to Apache, for example. So you could just put it in front of Apache, have it listen on port 80, and have Apache listen on port 8080. And then it would just redirect, basically proxy anything else to Apache. That's one way of doing it. The better way to do it, the proper way to do it nowadays, is using Nginx with PHP FPM, which has been around since 5.3.3, so I guess we're all running that right now, right? And then that runs on port 9000 or with a Unix socket file. If you run it on port 9000, it uses fast CGI to connect to it. And then this is the way you do it. You just say fast CGI pass to this specific IP and port, so you can run it on a separate machine even, and pass along all the parameters and so on. So this PHP FPM will be a separate process running all your PHP stuff, and Nginx will just connect to it. The big advantage of PHP FPM is that it's very fast, and it will allow you to do graceful upgrades. So you can upgrade from one PHP version to the next, and it will continue running your old processes and will start up with the new version. You can automatically spawn new processes when it has a high load. You can do shooting, which is kind of interesting because you can actually say, okay, I want you to run that site under that user in group permission, which is sort of what we tried to do with safe mode, but that never worked out. And it also has a very nice feature called slow request log, which is very similar to the MySQL slow request log, except that this one does it for PHP. It will tell you, oh, this script has been running for 15 seconds now, and I'm stuck on that line right now, so you should definitely check out this PHP code because it's running kind of slow. And it also has a thing called fast CGI finish request. What this allows you to do is, for example, let's say somebody uploads an image and you have to create a thumbnail of it, but you don't want that user to wait until you've actually created the thumbnail. You want to immediately tell them, okay, thank you for uploading the image. You can just say fast CGI finish request. It will return to the web server and say, thank you, and then it will continue to run whatever code you have defined after that. So if we look at that original benchmark here, then we can see if we replace Apache by Nginx, suddenly we get a number that's a lot higher. Now the odd thing here is that this number is not higher, which it should be, but the problem is that I was testing using Apache Bench, which uses one CPU, and it just couldn't request more than that. But if you want to know how far you can push Nginx, this is very unreadable, I think. Basically, this is a little benchmark I did on an 8-core machine, and it's doing 115,000 requests per second. This is on a static HTML file, not with PHP behind.
How big?
How big? That's a good question. I think it was something like Hello World or something.
Okay.
But honestly, it's not going to matter much. The limit you will more easily hit here is your network. If you put like a couple of 100 kilobytes in there, then 115,000 requests per second is going to hit your network limit. Okay, so we talked about the database of it, we talked about that part. Let's talk about this part here, the reverse proxy. Has anyone ever worked with Varnish? You? Okay. Varnish is a load balancer, yes, it will balance the load across multiple web servers behind it. But it's also a reverse proxy cache, also called an HTTP accelerator, or there's plenty of other names for it. It will cache images, JavaScript, and so on, other static stuff, and it will cache entire pages, static pages, or even parts of the page in its internal memory. So it doesn't use memcache. This is a very simplistic configuration file. So we have a backend, which is a web server basically, that we define with an IP address. We have another one, and then we group them together using a director. We give it the name. We say round robin, basically meaning pick one, then pick the other, pick one, pick the other. And we provide it with our 2 backend servers. That's a basic configuration. If you set this up, Varnish will just automatically work. Any request will be spread across server 1 and server 2. Now, of course, if server 1 were to fail, for example, then you would have a problem because it would try to get to server 1 every now and then. But built into Varnish, there's a health system, health checking. So you can do a probe. You can say, oh, check this URL, do it every 5 seconds, wait 1 second for it to time out, and then if 3 out of 5 requests fails, then consider it down. Consider it offline. It will automatically take it offline. It will not make any requests. It will not send any requests anymore other than the actual probe here. And then if it is online again, it will automatically add it to the pool. Now Varnish has a system called VCL, which is the Varnish configuration language. And it's the way you define everything in Varnish. It compiles itself to C on reload, and it hooks itself into every single request that you make. And it allows you to do very nifty things like you can do flood detection, you can do access control, you can do load balancing strategies, and so on. It's extremely flexible. You can almost program it actually. And you can reload it while it's running. We'll just recompile it automatically and keep on running. You also get very, very cool console-based statistics, which I don't think anybody ever uses, but anyway. And it also has a feature called ESI, which is edge side includes. Now this is a technology that was developed by Akamai, the content distribution network, a very long time ago, back in 2001, I think. But what it does is it will allow you to split up pages in different blocks and cache them separately. So let's imagine that this is what our site looks like. We have a header with our logo and a couple of other things. We have a navigation, where we have our entire menu structure, and we have the latest news, which we could update regularly, I guess, and then the actual page content. Now that top part with our logo is probably not going to change a lot. So we might want to cache that for like a couple of hours or a couple of days even. So what we can say is, okay, I want to cache this for 2 hours, I want to cache the navigation for an hour, the latest news only 2 minutes, because that could be updated quite a lot, and the actual page content, well, maybe 30 minutes. And then what happens is, if the user requests our page here, then Varnish will say, okay, /page, I don't know what /page is, let me get /page from our web server. And PHP is going to return /page, and it will contain something like this. HTML, we know that tag. ESI, include source equals top. Now if we send this back to the browser is just going to ignore that. It doesn't know what to do with it. Luckily, Varnish does know what to do with it. And it says, okay, ESI include source equals top. It means I need to replace this tag by whatever is in /top. So let me get /top. And then PHP is going to return /top, and it might be a div with a login, for example. And so what's going to happen is it's going to replace that ESI with /top. And it's going to do that for every single of these ESI blocks. And then you can define in the VCL, the Varnish configuration language, how long it needs to store this information before it's expired. And so what could happen is that it will not retrieve any information from your web server anymore until after 2 minutes the /latest news here expires. And then it's going to make one request to the latest news, and then again serve everything from memory again. So this could be, go ahead.
Yeah, so this is the scripting language that Varnish translates into C, right?
Yeah.
Okay.
Right. So this could actually, if you have a very static site, or even if you have a dynamic site that doesn't change a lot, you could get enormous improvements in terms of performance. Because you're basically not hitting your web server with PHP every single time. So you can cache static pages, images, JavaScript, CSS, or with ESI, anything that doesn't change a lot. You can, of course, not cache post requests. Post means update, it needs to go to PHP every single time. You cannot, well, you could cache very large files, but it's not designed to do it. And then the other issue is, anything with a cookie cannot be cached. And the reason for that is very simple. If you have a session cookie in there, you are logged in. And Varnish doesn't know what to present to you, because it should say something like, for example, you are logged in as me, and you have 5 messages.
Question, what if you wanted to display content that is, with a session cookie that is static in combination with dynamic? Could you combine it?
Yes.
To say, for this one, cache it even if it has a cookie.
Yes. You can, in the VCL, that configuration language,
Okay.
you can say, for these URLs, ignore the cookie.
Okay.
And then it will still cache it in internal memory. So Varnish cannot do this. It might be able to cache stuff on the left here for an hour, maybe even that content if it's not user specific and you strip away the cookie. But that top part, it cannot cache that. So the TTL, the expiry time is going to be 0 seconds every single time. Which is kind of a bit of a problem because, well, basically we're all building user specific sites. We all want our users to be logged in, we want them to have their own favorites and their own friends and stuff like that. So Varnish doesn't handle that by default. It has what I call a semi-functional way of doing it, which is you can do very dirty stuff in VCL, very messy. Yeah, I don't advise you to do this. I know some very big sites have tried to do it and have come back from it because it just is not maintained. So it's not very proper to do it. The way it works basically is by sending a request to Varnish, connecting from PHP to the database or whatever you're doing, you're going to get a UUID back, and it's going to actually delete that from the memory varnish. The next time it's going to be updated, and then it's going to have to re-request it. It's a whole bloody mess. So really not the right way. There's a better way of doing it. There's a varnish module called vmod memcached, which connects varnish directly to memcached. It works pretty well, and it will speed up things, but it's still kind of a pain to set up, and it only works for stuff that you store in the actual session information. You cannot store other stuff, you cannot store blocks of information, entire pages or anything like that. I'm quickly going to talk about another way to do it, but it's not available yet, which is why I'm going to skip over it pretty quickly. Based on Nginx, something that links directly to memcached, to Redis, to Couchbase, and all the others, with session support, and theoretically gets you to the point where you can have 0 GET requests and everything's served from cache. But it does require quite a few code changes. And the way that works is basically instead of doing that every single time and going to the database and memcached, we just do that. So we link Nginx with a system called Slick directly to memcached. This is a system we built a couple of years ago. To give you some idea, this is kind of load drop you can get on. This is one load drop we had for a certain customer. We had that system, but because of copyright issues, we cannot release that, so we're working on rebuilding it completely. Yes, we'll open source it, but it's a spare time project, so we don't know when it's going to be ready yet, hopefully pretty soon. Okay, so we talked about caching, we talked about replacing part of our stack. It's time to talk a little bit about the tuning part. So let's start with who's still using Apache as their main web server? Quite a few people. Okay, so let's talk about Apache. A couple of tips to tune Apache. You can start by disabling any modules that you don't need. By default, most installations will have like 30 modules enabled in Apache. If you disable all those that you don't need, you fix quite a bit of the performance issues. You should always set allow override to none. I know it's a pain in the ass. It's easier to set allow override to all so that you can do whatever you want in your htaccess file. The problem is that if you have an htaccess file and you set allow override to all, and let's imagine that your web root is located in /var/www/html/some site/public content/ what else, then it's actually going to check for a .htaccess file on your root, on your /var, on your /var/www, and so on. So it's going to do a file system operation for every single hit that you have on every single subdirectory that you have above your web root, which is going to be very inefficient. And it's going to do the same thing if you have symlinks if under match enabled. So setting allow override to none, and then only setting it to all for that specific directory when you need it is a much more efficient solution. Yeah, min spare server, max spare server, start server, max clients, npm, and so on. I'm not going to talk about that. That's an entire session on its own. Don't use mod proxy. If you have Nginx and if you have Varnish, why would you use mod proxy? It's a lot faster to use Nginx than Varnish. And if you have SSL running and you have a high load, again, put Nginx in front of it. It can cope with SSL a lot faster and just use it as a reverse proxy. Some PHP speed tips. Upgrade PHP, yes. Who's running 5.2 on production still? 5.3, couple, 5.4, 5.5, 5.6, 6.0, 7.0 in production? Nobody yet? Okay. So upgrading. Every single release has a huge speed gain. 7.0 is anywhere between, 150 and 300% depending on your code, and reduced memory usage. Use an opcode cache. On 5.5 and above, it's included by default. On others, you can use APC. And profile your code. xhprof is your friend, xdebug is your friend, and if you use xdebug, you can get the output of the XDebug trace and run it through something like a cache grind, and it will tell you, oh, this is where your code is spending that much time in detail. Let's talk about database tuning. Avoiding dynamic functions, always a good idea. So if you have a query like this, where you have where date column equals per date, then that's a dynamic function, and it's actually not going to use the query cache properly for that. So it would be better in PHP to just say, that's the current date. And then it's actually probably going to cache it. Use the same types for joins, meaning don't join a decimal with an int, for example. That's very inefficient. Use the proper indexes. Not too many, not too few. That's all separate sessions. Order by rand, I don't think I have to explain that that's very easy. And selecting the right storage engine is definitely a good idea as well. I'm going to skip over this one for a second. Okay. So quickly, I said I was going to talk about front end. This is a graph showing how many objects and how many megabytes are on a page from 1995 to 2009, and the graph goes even straighter upwards after that. So as backend engineers, you spend a lot of time optimizing the backend. And then some front-end engineer comes along and decides to send 1,500 AJAX requests per page, just because he can. And then, of course, who's going to blame you? Well, your boss is going to blame you, of course, because, well, the backend is down. So let's not forget the front-end send requests to the backend. So if they don't know how to behave, then we should basically tell them. We have to care about the front end. We have to test those sites. We have to see what the front end is actually doing. And so we can tell them, for example, to minimize requests by combining all CSS files, by combining JavaScript files and minifying them, using CSS sprites. Anyone using sprites? Not too many. Okay. So, for example, this is a sprite containing all the images used by Google on their homepage. This is one image. Same thing for the sharing one. This is the sprite containing all the images on the Amazon site. And they are all just one image. So, for example, these are 11 images. If you want to retrieve them all on a web page, it takes 11 HTTP requests and 24 kilobytes. If you put them together in one image, it's one HTTP request, of course, and 14 kilobytes because of PNG compression. And there are plenty of tools that will do this automatically, create CSS for you, that will automatically select the right file.
And we also, it's not just bandwidth, it's also the latency of packets.
Yeah, absolutely. Latency and how much time it takes for the browser to process everything, and so on and so on. There's a lot of advantages there. Put CSS at the top. The reason for that is very simple. If your site takes a long time to load, at least it will load. Put JavaScript at the bottom. The reason for that, again, is you don't want to freeze your page because it's processing JavaScript and it cannot continue to load. So the reason is that you have a maximum number of connections that your browser can open simultaneously. So if you have a lot of advertising scripts, for example, it's going to open requests and it cannot open any more requests until it finishes whatever it's doing. And again, because of maximum connections, avoid iframes. They also contribute to that maximum number of connections. Don't scale images in HTML, I don't think I have to explain now. And have a fav icon. Now that might seem like a very weird one. If you're interested in figuring out why, go to my blog, there's an article about that. Some very big sites are doing it wrong and wasting a lot of megabytes in processing power. So what else can kill your site? Well, anything that redirects or anything that sends your customer to a different location basically means your customer has additional latency and your site is processing more code. So try to avoid sending your customer to other locations. There's different ways of doing that, proper ways. With most modern frameworks, you can internally forward it to a different location. Watch your logs. But equally important, watch the logging process, because logging means this kind of that can actually kill your server. But oops. I'm out of time, I noticed. I'll put these slides online in any case. So cache, don't delete, have a warm-up script, monitor your cache. Have an abstraction layer if you want to switch from one cache to the other. Apache, yes, great, if you tune it properly. Nginx is a little better. And then if you have static pages, use Varnish, and don't forget about front.
Great, thank you.